Hello everyone, this video is all about ATP production for the common metabolic pathway. So we are already familiar with the definition of this one. This is defined as the sum total of the biochemical reaction in which that is the ATP that is being produced in the citric acid cycle and electron transport chain and oxidative phosphorylation process. So in the electron transport chain video that you have watched, you have encountered there the transition of ADP to ATP. So this is what we call the oxidative phosphorylation, the addition of the phosphate here to produce the ATP or the energy currency of the cell. So for this video, we will be counting how many molecules or how many pieces of ATP is produced in the metabolic pathway. So for here in the citric acid cycle, as you can remember, in the general overview, we can define the electron transport chain based on the number of the reduced nicotinamide adenine dinucleotide, flavine adenine dinucleotide that will undergo into electron transport chain for them to be converted into the ATP. So itong reduced form dito ng NADH, then the flavine adenine dinucleotide here, it will be converted into ATP in the electron transport chain. So these are the another byproducts of the citric acid cycle that will undergo the electron transport chain to produce the energy currency of the cell, which is the ATP. So here in the citric acid cycle, we have 3 reduced nicotinamide adenine dinucleotide that is being produced. We have here 1, 2, 3. So this one is produced in the formation of alpha ketoglutarate from the isocitrate. This one is produced from the formation of succinyl-CoA from alpha ketoglutarate. And this NADH reduced form here is produced from the formation or regeneration of oxaloacetate from the left-handed malate here. And we also have here the reduced form of flavine adenine dinucleotide from succinate-CoA to fumarate. And then we also have here the JTP or the guanine-based energy, which will undergo this. These byproducts here of coenzymes will undergo the electron transport chain process and they will be utilized in the production of ATP. One piece of nicotinamide adenine dinucleotide can produce 2.5 ATP, while a one piece of flavine adenine dinucleotide, the reduced form, can produce 1.5 ATP, and the guanine triphosphate can produce 1 ATP. Since the citric acid cycle will produce 3 reduced form of nicotinamide adenine dinucleotide, that will be equivalent to 7.5, since one piece of this is equivalent to 2.5. So that is 2.5 times 3, you will have 7.5 ATP, and 1 flavine adenine dinucleotide, the reduced form, not the oxidized form, you will have 1.5 ATP, and 1 guanine triphosphate will produce 1 ATP. So overall, the total number of the common metabolic pathway for the ATP that is produced or that has been produced is equals to, if you will add that, that is 10 ATP. So meaning to say, one acetyl-CoA that will undergo the process in the citric acid cycle can produce 10 ATP once it reaches the electron transport chain and oxidative phosphorylation. So that is all for this ATP production for the common metabolic pathway.